This course is about the electrical system of the DigiEye280, and it is the second specialized course of DigiEye280. In this course, we will learn the electrical structure, including the system power on sequence, the generator electrical, mechanical electrical, and the system control box. And we will focus on the connection between each module, the principle of the board indicators, and the test point, and so on. After this course, the engineer should understand the hardware structure, the function of each board, and understand the cable connection, indicators, and the test point. Okay, before our course, let's consider some related questions. First, how to contact each module of the DigiEye280. Second, how many balls in the generator, and what is the position of respectively in the generator. Third, what is the principle of each ball and its function. Fourth, how to control the brake of the DigiEye280. Fifth, what's the function of the table power box and the detector power box. The sixth one is where's power supply of the PC and monitor. And the last question is where's power supply of the collimator. This course contains of 6 parts. Product configuration mainly introduce the configuration such as the tube, detector, etc. The system connection diagram is about the electrical connection of the whole system, like the power connection, the ground and signal connection. The next one is the power on sequence. The generator and mechanical electrical will be introduced more detail about the connection. And the last part is about the PC and system control. Okay, the first part is about the configuration. There are 3 kinds of X-ray tube for DigiEye280. Toshiba E7876X, E7240X, and Kailong H1086. But this one has never been configured. And the difference between these 2 tubes are the unknown heat content and the power. We can see this tube has a higher and low heat content and power. It means that this tube used in a 50 kilowatt generator, and this tube in a 30 kilowatt for detector. Toshiba and Mirage detector can be configured. It contains of 1 Toshiba detector and 3 kinds of Mirage detector, and this one also has never been configured. Here, the number means the detector effective size, and the MPS detector has a better image quality than the EPX, and of course, a higher price. Let's see the default IP address for the detector and the net adapter. As you can see, they have a same segment and only different in last digit. Like the Toshiba detector, its IP address is 53, and for Mirage detector, the last digit is 192. And the net, except the tubes and the detectors, the generator's type is MHV50A, a 50 kilowatt generator, and the collimator is CS03, which is a full manual collimator. And besides, a Siemens ionization chamber, grid, and DAP also. And okay, the next part is about the system connection diagram. Here is the abbreviation of the components, and we will use the abbreviation in the course. Like the MCB, it means the master control board. As you can see, this is the whole system connection, the hospital transformer, the distribution room, the power distribution cabinet. And this part we will introduce in the pre-installation course. And we will introduce this part in this. Okay. Let's check the general diagram first. As you know, the different line on behalf of different signal. Like this free line, it means the 380 volt free phase power. And this is the 220 volt. The green and yellow line is the ground wire. The purple line is the high voltage cable, and the green one is the dry power, and the last is the signal communication. Okay, the diagram will be divided into different parts to first one is about the power supply. The 380 power comes from the power distributor cabinet via the table side connector TS1, and then pass the fuse F1 to the bucket interface. It will exchange to two parts in the bucket interface board. One is to the detector power box, another is to the table power box. And besides, in the equipment room, the PC and monitors power supplied by the wall socket. Under the table, the output of the table power box contains of 36 volt DC for the electromagnetic brake, and this 24 volt AC is for the collimator light. The tank transfers the high voltage to the tail by the high voltage cable. And in the last, the TS1 provides the door lock and the door indicator. The next part is about the grounding. As you can see, all the components ground wire should be connected to the PE port beside the generator, and then to the power cabinet. The last is about the signal communication. As we can see, all the signal created by the generator. For example, the J15 connector, which is the communication between the PC, the hand switch, and the generator. And this one, the J7 and J8, connects to the ionization chamber in the detector box. And this one, X-wire, used to control the system power on or off and the emergency stop. Okay, let's see the circle diagram for more specific. Here is the TS1 connector, which provides a door lock, the door indicator, and the power input. And the J15 connector, like I said before, used to communicate the generator with the PC and the hand switch. If this connector did not connect it, you will see the GA error display in the DROC. And like the S file, it comes from the generator to the system control box, used to control the system power on or off and provide the emergency function and exposure indicators. And this part is the detector and table power box. The power comes from the auxiliary power board and separated into two paths in the bucket interface board. And besides the detector and the PC, the third part is the system power on sequence. When three-phase power input is normal, the standby 24 volts of the generator is on. Here we press the start button on the system control box. The system control box will send the power on signal to the master control board as the generator and PC. Then the PC start up. After the master control board receives the power on signal, the power on signal will change to low level and send it to the auxiliary power board. And when the auxiliary power board receives the signal, it will output the different kinds of voltage. Then all the boards will get power, and the master control board begins to perform the self-test. After the self-test finishes, the master control board will send out the charge command. Then the small contactor will pull in, and the barcode capacitor start to charge. After the barcode capacitor charge to 480 volt, the signal sense will be changed to high level. And when the main master control board detects the sense signal has changed to high level, it will change the charge signal to loud level. And then the small detector will drop out, and the main signal change to high level. And in this time, the main contactor will be pulled in. Here it means the main power circle power on play. The next part is about the generator electrical, including the generator and mechanical. And first, let's review the generator structure again. In the front, you can see the transformer, the bucket interface board, the master control board, and flip the master control board. We can see the analog drive board, auxiliary power board, the filament drive board, and the three-phase power comes from the power distributor. The L1 and L3 lead to the charging circuit. This is the charging circuit to charge the buckle capacitor. The main power go to the EMC filter first, afterwards wire the rectifier, bridge, and the inverter to generate a high frequency voltage to the tank, and the tank will transform it to a high voltage, which provide the tube to generate X-ray. And the L2 and L3 line, they go through the liner transformer and exchange to different volts to all the boards, like the 24, 12, or 15 volts to the master control board, the 15 volts to the high voltage control board, and 28 volts to the filament driver board, and no control board is powered by the master control board, and it also has a high voltage from the auxiliary power board. Let's see the main power supply generating diagram. As you can see, the red line indicates the main power in the generator. The AC power go through the fuse F1 and the main contactor K1 and the inductance L1 first, then wire the rectifier bridge transform to DC volt, and afterwards a filter circuit to make the power more smooth. Next to the inverter module. For the 65 kilowatt generator, it has two inverter boards. For the 50 kilowatt generator, only one inverter board. And after the inverter board, the power will be transformed to a high frequency power, and at last transmits to the tank. Okay, this page is some pictures about the components in the main power circuit, like the K1, the main contactor, the inductance L1, the EMC filter board, the rectifier circuit, two large buckle capacitors, and the inverter board, the resonance circuit. Let's learn the EMC filter board. This board mainly includes the resistance and the capacitors, and its function mainly restrict the intrinsic voltage of the main power, provide a different mode noise filter and provide. For the inverter board, its function is generate a high frequency AC signal to the resonance cavity. And this is the inverter board picture. The next is the tank. It receives the power from the inverter module and generates the high voltage and filament current to the tube under the control of the host computer. Okay, about the auxiliary power board. From its name, we know that it provides the power for all the boards in the generator. So let's learn the connector circuit. The 380 volt AC power leads to the transformer through the auxiliary power board and output different kinds of voltage to the other boards. As the diagram shows. Besides, this is the charging circuit. When power on the generator, the auxiliary connector K2 is activated and the barcode capacity start to charging. After the charging finish, the auxiliary contactor switch off and the main contactor switch on. Then the main power circle begin to work. According to the circuits I told you before, what are the functions of the auxiliary power board? First, transform the main power to rotation analog board. Second, restrict the circle current when system main power circle is power on. Third, power on or off control function of the system main power circuit. The last, after power off, discharge the barcode capacitor of the main power circuit. And this is the picture of the auxiliary power board. And we can see the connectors definition here, and you can learn it by yourself. The next part is the mechanical electrical. Except the generator, the mechanical electrical is also the mechanical electrical mainly contains of the table power box. The power box is located under the right side of the table, and inside of the table power box, you can see the switching power box, which transform the 220 volt AC to 36 volt DC, which is supplied to the electric magnet. And the power supply board will output a 24 volt DC to the control buttons in the tube collimator assembly. And this is the transformer. It will output a 24 volt AC to the collimator light. And this is the relay and the fuse holder. From the diagram, we can see the table power box power comes from the bucket interface board, and its power transmits to different electron magnets, the collimator, and the control button on the tube collimator assembly. And here is the table power box control circuits. We should know how to read the circuits. For example, the collimator light. The transformer receives the 220 volt AC power, and it will output the 24 volt AC via a fuse. The S26 connector, and at last lead to the collimator light, and the others are similar with the okay. The last part is about the PC and system control box. First is the system control box. Its function including of the exposure, emergency stop, one button to power on the system, to shut down the system, and this is the exposure indicators. The green one stands for the preparation, and the yellow stands for exposure. This is the power indicator. It has two status. When blue indicator is on, it means that the system is in working status, and if the indicator is off, it means the system is not working. And the force shutdown function, you can press the shutdown button few seconds, and the whole system will be shut down in short time. And besides, the power indicators also can blinking in different frequencies. Slow blinking means that the generator do not power on totally, and fast blinking means that the emergency button is pressed. If the system control box defective, we can replace the whole box or only replace the. This is the connection circuit between the system control box and the PC. There are 3 cables behind the control box. This one, the X6 connect to the generator to communication. The X7 link to the startup interface board in the PC to control the PC power on or off. And the last one is the ground cable